So, welcome everyone. We're going to be trying to do this semester and going forward a bunch of quick summaries for each lecture. And we're going to start with the first one for Civil 398, Civil Engineering Systems Design, where we'll try to explore the fundamental ideas and the foundational ideas of each lecture so that, you can review really check your progress as you go with the course. And in the first lecture, we tried to look at what makes the material important, right? What are the main drivers behind its importance? So, the main way we do that is to truly understand any science. Islamic scholars in the past proposed six essential questions, and they are: what is it? Why study it? What does it consist of? And how is it studied, right? Along with how does it relate to other fields? And finally, where did it originate from? So, what is the origin of the science we're talking about right now? So, let's start with what is it? So, what is civil engineering system design? It is the study of the integration between the physical element, like roads, bridges, treatment plants, and operational rules that govern how they work together. So, a bridge without transportation rules like red lights, green lights, when to pass, what are the rules of the lane, what is a service lane, is just a structure. Then it can become part of a highway or the road or the overall network when it has certain rules to plug into the whole system. So, as you can see on the slide, for example, let's look at the solar system itself, which is a huge anecdote, right? If the stars and the planets did not move in a certain way, in a certain order, if the sun wasn't at the center at all of it, it will be just a bunch of cosmic bodies. Once they rotate around the sun in a certain way and the sun rotates around itself in a certain manner, there are the sets of operational rules, then we have something we call a solar system. Otherwise, it would be a star and planet A, B, C, and so on. So, studying civil engineering systems equips us to address the most urgent challenges of our time, such as urbanization, climate change, infrastructure resilience. These systems shape society. I mean, these are the systems we live in, really. So, they impact us by affecting economic growth to public health, cultural identity, infrastructure drives, and progress. So, as engineers, we are responsible and called to create systems that are not just functional, but also sustainable, equitable, and forward looking, right? So, in other words, to simplify it, it's about doing things better, cheaper, faster, but never, ever compromising on quality. Quality is part of safety, and safety is the number one thing in civil engineering, right? Safety of the people is above all else, above all costs. So we need to always make sure people are safe, short term and long. And so, what does civil engineering system study consist of? Well, all the subdisciplines, really. We have structural, geotechnical, transportation, hydraulic, environmental, construction engineering, you name it. I mean, any field we can optimize and do some mathematical work with it. Most of the civil engineering fields are not abstract, they have physical components like materials, structures, and abstract elements and components like safety protocols, rules, how to do certain mixed designs, So all these details represent the system. For example, efficiency guidelines, sustainability goals, and so on and so forth. So, how do we study civil engineering systems? We use an engineering mindset, which is, well, as you know by now, a lot of math. So this means breaking down these complex problems into small, manageable parts that are mathematically logical, that we can understand through math and interpret and determine using proper math. So we use tools like modeling, simulation, optimization, economic analysis, you name it. All of these guys, we use them as the tools for our study. Also, decision theory. All of this leads us to the idea that how do we make informed means we know what we are talking about, ethical. So ethics is very important. It needs to be the right thing and the right time for all people. Under uncertainty, which means we don't have all the given. The situation seems messy, not very well understood, right? So we want to mathematize it as much as possible so that we would have, this touch, this hint of reality that we are getting closer to what is actually true as much as possible. And then we use our engineering judgment and our thinking to really finalize the last decision. Now, how does it relate to other civil engineering fields? It's interdisciplinary. It works with everything. Everything we do has choices, has different variables. And the whole field, we get it from physics, mathematics, economics. We use a lot of economics as well, and the understanding of the flow and the cycle of money and life cost evaluation and how long does an object last. We even study sociology and urban planning to make sure we are shaping cities properly and in the right fashion. We study environmental science to understand the impact of some of our work. And that's why, like, one of the big things nowadays is how much carbon emission does producing concrete and cement does and harm the environment, right? So where did it originate from? Civil engineering and civil engineering studies and systems is as ancient as you can think of. Like from ancient Mesopotamia, Egypt, Rome, there are examples of civil infrastructure like aqueducts, roads, bridges that until today they're still standing and they're landmarks and they are revered. And, most of us know most of them. One prominent one is the Colosseum. So leading to today, the discipline has evolved to include digital modeling, automation, the things you do with robot, Rivet, all these structures, smart infrastructure, or these structural tools. That's a nice anecdote. The smart infrastructure nowadays that adapt using sensors to new coming information. And therefore, the mission is kind of the same, to serve society through well-designed systems. But now we have better tools and we can do it faster, better, but we have really creative ideas that we can use right now. So going forward from this point, I assume you should have read chapter 2 and maybe chapter 1 if you really wanted to understand the civil engineering history. And then we will move on to the remaining topics as we go. Good luck.